So thanks very much. This is a wonderful meeting, and I'm glad to have the invitation. And actually, in the taxi ride on the way over, the taxi driver, who was a wee bit scary, said, "Oh, you must be here for math." And so it's the first time I've had somebody assume I was here for a math meeting. So I was really excited. Everybody at the 4 Points is here for math, so that was really cool. So today I thought, much like some of the other speakers, I'll give you a little a taste of what I've done and how I got to where I am. Maybe a little bit less of that than some people. But if you have questions, I'm really informal, so just ask, and I'm happy to answer those questions. Oh yeah. So, and if you get car sick, get ready. So this is Prezi. It's a new software, and it's a horrible use of your time if you don't have tenure already, because there's a really steep learning curve. But if you have time to play, then it's fun. So you've heard some about biostatistics from Susmita yesterday, but I thought, like Julie, I'll give a definition to start. So biostatistics is a branch of mathematical science. We're focused on developing and applying statistical methods, in particular to analysis of public health and biomedical data. Okay, departments of biostatistics, the big ones are generally in schools of public health. So that'll be a mostly graduate school, though often there's some undergraduates. There are some departments of biostatistics in medical schools. Often those are smaller. But not always, so it just depends on the structure. And our work is pretty different, and so I'll talk a little bit about sort of the parameters of the jobs, but in general we're expected to do both development of statistical theory and also very hands-on application of theories or of existing statistical methods to and the appointment is very much a mix of research and teaching. And so our load in biostatistics at UNC is 1-0. So you hear the whining of, oh God, I'm teaching this semester, as opposed to I'm teaching 4. But in exchange for that, we're expected to bring in 60% of our salary on external funds. So those could be grants for which we're the PI. They could be grants for which other people are the PI, but we're the statistical analyst on the grant, and it can be a mix. So for most people, we like ideally for that to be a mix, have some grants as PI and some working on other people's grants in collaborative teams. So it's sort of like the stat, if you're in a regular stat department with a 2-2 or 2-1 load, it's sort of like buying out your summer in 2 courses is how I explain it to friends. So it tends to be a similar arrangement. And when you're not teaching, so this semester I'm not teaching, and so really I don't have to be there as long as my work gets done. I mean, it's good to be there, but nobody, if I disappeared for a month to work with a colleague at a different university, my husband and kids might complain, but the department probably wouldn't as long as I told them in advance. So how did I get into biostatistics? How did I even figure out what it was? Now, I don't know many people, unless their parents are biostatisticians, who grow up saying in 3rd grade they want to be a biostatistician. It's sort of a new field. So I started out at another SEC school, the University of Mississippi. So I grew up in Mississippi. And this is the main, this is where the chancellor sits, the main administrative building there. And I went there as an English lit major. And before classes started, I added math as a major, but I was a little not so confident because I went to a really small high school, i.e. I didn't have calculus in my high school. And so I started out in undergrad in Cal 1. And so I liked math, though, and I added it my first semester as a double major. And so as I went forward in my career, or at undergraduate, I really liked English because I liked to read, but I couldn't see myself being a professor of English because I didn't really like that type of research. I just really liked to read for fun and get grades for reading books and writing about them. So I started to look at math, and with math I felt the need to see more of an immediate impact of my work, and I wanted to feel like I was doing something and getting feedback for what I did and seeing how it changes the world. And so that's how I learned about biostat. Actually, a biostat professor came to talk in our department. It was a math department. And the chair of the math department at the time said, "Oh, don't bother going to that talk. Biostat is wussy." And so I skipped the talk and found out from a friend later what it was about. And ended up at Harvard, which is where the professor was from. So I got to know her very well. She's no longer there. She's in Australia now, but she was actually at one point chaired the department there at Harvard School of Public Health. And so they have, biostatistics is sort of unique in that you can go straight from undergrad into a PhD program, and maybe the majority of U.S. students do that, and often international students do have a master's first because it's so much more competitive, for international students to get into graduate programs in the U.S. So that was a great experience. And then again, unlike maybe math, in biostat, it's possible to go directly into a faculty position without a postdoc. So after I got my PhD, I was offered a job at UNC, which I was very excited about. Being a Southerner, I was glad to get out of Boston. It was nice. It was a great place to be for 5 years, but I like this. Chapel Hill's sort of halfway in between the North and the South. You can have sweet tea, but the winters are a little bit better, and people, hold the door for you when even the same gender, they will still leave the door open instead of letting it shut in your face. And so that was something else I appreciated there. And so I rose through the ranks at UNC. So from assistant to associate, and from associate to full professor, are all at the same institution. So that's a little bit about how so very linear, very boring compared to most people maybe. So I didn't have many twists and turns. I didn't have much real life experience before I got into my, my job. So talking a little bit about my research in general. So I do a mix of sort of theoretical, or we might call it methodological research. And those areas I'm interested in correlated data, like multivariate data or longitudinal data where you follow people over time. I'm interested in exposures that might be moderate to high dimensional, and I'll talk about some of the sort of moderate dimensional ones today. I'm interested in missing data. So often we don't know things for specific reasons, so I might not answer a question because I don't want to tell you, because I'm embarrassed. And also in incorporating biological or prior data in models, and in particular in Bayesian inference, informative Bayesian inference. And then from the application side, so generally we kind of have these split personalities, right? We've got our theory interests and our applications interests, and hopefully they overlap. And I'll try to explain how they do that a little bit today. I'm interested in reproductive health, environmental health, and maternal and child health sort of grew out of the first two based on the research interests of my colleagues. But when I came to UNC, I was mostly interested in environmental health, and so a lot of my projects got started that way. So what I'd like to do is talk about three kind of themes of research, and talk a little bit about how they affected my career. And so the first little research vignette I'll talk about is a study of healthy babies. And so this was called the Pregnancy, Infection, and Nutrition Study. It was carried out at UNC. It was 5,000 women over 3 NIH R01 grants. So these are kind of big research grants at UNC that went to my collaborators. Now, something else that's different in biostatistics is that paper counts are high. Okay, so you're expected to do a lot of collaboration. You're expected to publish a lot because you're teaching one course a year. So what are you doing if you're not publishing? So, going up for tenure, our dean likes to see 40 papers at the time of tenure. That's her preference. Doesn't always happen that way, but that's, and certainly there's a quality versus quantity issue that has to be addressed in the package as well. But that gives you some idea of like 40's not like, oh my God, I'm a rock star. 40's just maybe somewhat typical of somebody at my stage in my field. And so this was, though, a very fruitful collaboration in that a lot of my applications papers were based on this study. And actually, the nice thing about it is working on this study, I got lots of great ideas for methodological and theoretical research. And so that's one thing that sort of characterizes biostatisticians who are successful is you start working on a project and you think, gosh, existing methods don't really answer this question very well. How can I improve on what's out there in order to get a better answer to this scientific question that's really of interest? And so their science feeds your science and your science feeds their science, and it's very collaborative. So just to give you kind of a sense of some of the papers that came out of this work, and the types of journals. So we published in kind of different journals. So this would be a collaborative paper. I was, second or something author on this paper. And it looked at self-reports of how active you are. So you can imagine, if you ask somebody how much you exercise per week, maybe you pick a good week, or an optimistic week. But then they also had the women wear accelerometers, the little boxes, but this big or slightly smaller, and they saw what they really did. And so you can get some idea of how they overestimate how active they are, for example. And this was women postpartum, so right after they give in childbirth. So the moral of this story was women really aren't excited about exercise right after they've given childbirth. They've got other things on their mind, maybe. Some other papers we looked at cocaine exposures in preterm birth. That was also in an applications journal, a medical journal, Obstetrics and Gynecology. And then we got really interested in looking at trajectories of weight gain in pregnancy, patterns of weight gain, and outcomes for the baby. And that was something that we had a hard time using existing statistical methods to address. And that resulted in a paper that appeared in JASO, which is Journal of the American Statistical Association. So that's a very theory-oriented stats journal. So, you know, we publish sort of in both fields. So all the collaborative papers here that I've shown you, I was not first author on. I was just a collaborator. The JASA paper was mine. That was my baby, and I was the primary author on that one. So I want to talk about another applications paper in just a little bit more detail and give you an idea of what we did. This was a cool study of stress. And so what, in the study, they had done some prior work on stress and birth outcomes. And some studies showed that stress was bad, and you should avoid it, and had negative consequences for the outcome of interest is preterm birth. So that's a term birth is 39, 40 weeks. A preterm birth is before 37 weeks of gestation. So, the studies had shown things both ways. Some studies had shown stress was good, and some studies had shown stress was bad, and so there wasn't a good feel for what was going on. And so we wanted to use statistical methods to get a little more into this. And so the study itself had used what's called a life events questionnaire developed by Saracen. And they had questions about whether any of 39 different things had happened to you while you were pregnant. And then if you said yes, it happened, then they asked you how good or bad it was. Okay? And so some of these were kind of minor things, like a change in your eating habits. Well, most people do have some change in their eating habits. If you've been pregnant, you know. And other things, a divorce, maybe are relatively rare in the pregnancy. And so the interesting thing about these life events is that for every single one of them, some people thought they were good and some people thought they were bad. So -3 is like the worst possible, 0 is no effect, and 3 is really good. So you can see, like, new job. That's all over the place because maybe you wanted a new job and maybe you didn't. Divorce. So that was actually viewed more as positive than negative. Maybe because if you're mad enough to get divorced when you're pregnant, you're really, really ready to be rid of him. Marriage. So again, you can see, there's some combination of people that are really excited to get married and maybe people that feel like they have to get married because they're pregnant. Even death in the family, which you would think would almost always be bad. You're starting to wonder, are these husbands and they're done with them? Or, you can imagine if if you have an older relative or somebody who's suffered a long time, then you might actually view that as positive for them to pass on and be out of their misery. So the other thing, in addition to just some people seeing things as positive and some things being perceived as negative, is that these things also some of them are more extreme than others. Okay, so for example, a change in your eating habits, I think most people when they're pregnant expect this to happen. So even if you think it's very bad, it might not be as bad as a death in the family that you perceive. If your spouse dies or your partner dies while you're pregnant, that may have a lot bigger impact on your stress level than you just can't eat very well, or even if you have extreme nausea and vomiting, it's probably not as bad as that. So we were really interested in how best to analyze the data. And so in terms of methodological development, we were developing a model that allowed different events to have different impact. So maybe, regardless of how it's scored, having a death in your family has a bigger impact than changing your eating habits. Okay. Also, we felt it was important to have a different reactivity specific to each woman. So I think we all know people who, no matter what happens, it's either really, really good or really, really bad. Versus people who are just like, oh, everything's fine, and maybe they're just going to code everything in that -1 to 0 to 1 range, whereas other people are going to say it's -3 or +3 or -3 regardless. And so we wanted to account for the fact that some women will tend to give more extreme responses than others. We wanted to allow events to have both positive and negative impact because even things like death in the family, some people said was positive, and so we didn't want to assume that death was always bad. And that, a change in your financial status was always good, for example. Things could go both ways. And so there was a literature on discrete choice models and on cumulative ordinal models, and we sort of combined that literature with some new ideas to come up with our new statistical method that we published in Biometrics, which is a kind of a big biostats journal. So one of the more interesting things we looked at in terms of the biggest stressors, so the things that contributed most to stress, On the positive side, they were marriage. So if you planned a wedding, you know marriage can be stressful, though in a good way. Engagement, change in family closeness, change in church activities. These were the things that tended to have the biggest contributions in the positive stress level. On the negative side, a change in the number of arguments, a change in the financial status, separation, change in family closeness. So you see change in family closeness actually had strong impact on both types of stress, depending on how the woman rated it. And then when we looked at the association between stress and preterm birth, we saw that the things that impacted negative stress levels, so they had the minus side, they were bad, but things on the plus side didn't have any effect. So it was pretty interesting. This was a lot of fun, and I really felt like in this project, you know, we got a different answer because we used maybe a more specifically tailored statistical model than we might have been able to see with some sort of naive method where we assumed all stress was bad or something like that. The outcomes of this down the road, you know, this big study, I made a lot of long-term collaborative relationships that are still ongoing. And this was something I started in maybe my first year on the job. We got multiple grants after this where we're continuing related research. I got my own grant, an R03, which is a little grant from the NIH to develop statistical methods that were related to the project. And then one of the other collaborators in the study was somebody I ended up collaborating with in another grant. And with my collaboration with him, I had some even more interesting statistical methodological issues that led to an R01, which is like a big federal grant. So it was really productive. Just getting involved in this one study for me really was sort of life-changing or career-changing. So now, one of the people on that project had a friend, Carolyn. Carolyn's a nice person. And so she said, go talk to Carolyn. Carolyn has this study, and I think you would like to work with her. So because Carolyn was a nice person and I trusted my friend, I went to talk to Carolyn. And that's how I got involved in this work, which is you know, evolution of sexual attraction, identity, and behavior. So I never would have told you I was going to grad school to work on sex, but I ended up doing that. There's a big study at UNC, the AdHealth study, National Longitudinal Study of Adolescent Health. And it's a population representative study of teenagers in 1994 and 1995. And they're in their 30s now, and they collected all sorts of highly confidential demographic, behavioral, contextual, and health data, okay? This study was primarily a study of sex. They added health to get it funded by the government, but they were really interested in sexual development. And in particular, the question of interest to my collaborator had to do with how people's attraction, behavior, and identity, with a particular emphasis on sexual minority status, changed with age. And so what the study asked is at multiple times, and so they had different study waves. So maybe they went in, you started when you were 15. They followed up with you a couple years later when you were 17. They followed up with you, 5 years later when you were 23, 5 years later when you're 28, and so forth. And so it's what we would call a longitudinal study. And in each study wave, they had some basic questions. So attraction, are you attracted to girls? Everybody got that. Are you attracted to males? Everybody got that. Okay, so we saw all combinations of answers, only females, only males, both females and males, neither. And then they asked questions about behavior. So these were fun questions. The number of same-sex partners and the number of opposite-sex partners. So as a statistician, there's a big point mass at 0, especially when they were younger. Okay, so the 13 or 14, there are a lot of them that have zeros. There was a wide range of answers. There was digit preference. So if you're interested in Corson data or measurement error, 50, 100, 150, then you get some 347. You're wondering if they have a belt or something where they've got some tally. There were some professional sex workers in the study, and then if you sit down and start thinking about, okay, you're somebody that hooks up at a bar every weekend, it starts to add up. You can see how they might get to big numbers like that. And then they had questions on identity. And so here you were has to say whether you considered yourself 100% heterosexual, mostly heterosexual, mostly homosexual, 100% homosexual, bisexual, or you didn't identify with any of those categorizations. And this was actually the most interesting variable when I sat down and talked to Carolyn, because it's a nominal variable. Carolyn would not let me put bisexual in the middle. She said, theoretically, that's not where it belongs. It's not like it's a continuum and bisexual is just sitting in the middle of, I'm not really sure whether I'm heterosexual or homosexual. It's completely different according to the theory. So I have this nominal variable that we want to look at longitudinally. We want to look at how identity is related to attraction and behavior with time. So we're really interested in correlations. with these categorical variables. So the question is maybe, maybe when you're younger, you endorse attraction to a same-sex person, and then later, as you get older, that turns into behavior. Or maybe it doesn't, who knows? And so she's really interested in the evolution of these patterns. So it was very interesting statistically because we had these categorical data on different scales and how do we characterize the association between these variables even at one time point and then as they change over time. So just some kind of basic descriptive statistics from this study. It was about a quarter of the women and about 10% of the men endorsed some minority aspect. So they had either had an attraction for the same sex, they'd had a behavior with the same sex, or they said they weren't 100% heterosexual. But then if you got to strict LGB status, so maybe having a current partner of the same sex or saying you're 100% homosexual, that was much fewer. Okay? And the correlations we're seeing do evolve over time. And so one thing that was really interesting, in adolescents, when they're in high school, there's a positive correlation between being attracted to females and attracted to males. So like more attracted is more attracted. But as people got older, that went away. And so there's some really interesting patterns there that we're continuing to explore based on this work. And so in this study, we've had a number of publications, and we have some interesting methods works in progress talking about how you measure changes in correlations with time when things are on such different scales. Now, maybe the most fun outcome of this paper, and this was kind of a one-week project last summer, led into the third vignette that I'll talk about here, which is virgin births. So this was a lot of fun. So we call this Sex Lies in BMJ. BMJ is a journal where a paper showed up. And this was a really fun collaboration because I got to work with a sex expert, 2 nutritionists, and a priest. So it was really fun. I'm from Mississippi. I don't like the thought of going to hell, and so I involved a priest who actually has a math PhD, an applied math PhD from Harvard, and he's also a priest, so he's a pretty cool guy, Bill Joyner. So we were doing some work based on predictors of long-term virginity, okay? And long-term, just in case you're wondering if that's you, they defined it in the study as beyond 18, which I thought was kind of strict. But anyway. And so what happened, we were looking at that Virgin Project where we found more than a handful of women that said they'd been pregnant before they said they had sex in the study. So at every study wave, they ask you about your pregnancies and when they were and all this. And then they have a separate set of questions about when you started having sex and when that was. And so when you match them together, you notice, wow, she had a baby, but she hasn't had sex yet. And it's not just the case of like maybe dates being off within the same year. The median time to having sex after pregnancy in this small group of women, because it wasn't huge, but it was 40, was about 2 years. And it ranged from 1 year to 18 years. And so, what's going on? So for our Virgin Project, we said this is just all messed up reporting. And so we excluded them. But then we thought, well, maybe it's worth looking into a little more what's related to this type of reporting. What's causing these women, what's associated with their reporting in this manner. So when we started looking more closely, we saw that there were 3 different groups of mothers. There were, normal mothers. I had sex and I got pregnant. Okay. There were virgin mothers. I have not had sex, and yet I have had a child, and it wasn't due to in vitro, and it wasn't adopted, okay, but I physically gave birth. And what we call born-again virgin mothers. And so these were women that, in one part of the question, early on in the questionnaires, at the first study wave, for example, said I've had sex. But then later, 3 or 4 years later, I've never had sex. And then you have a baby. So they sort of recanted. And decided maybe they really didn't do that, for whatever reason. They were they were the most interesting group. They had some kind of strange answers all over. But for the purposes of today, we'll avoid these born-again virgin moms for the most part, thinking that they're maybe more likely to be messing with the questionnaire or trying to forget a bad relationship or something like that, and concentrate on the virgin moms, so to speak. So how common is virgin birth? So based on this is a population representative study that should allow us to calculate prevalence. And so if you're a frequentist, which means you only look at the data in this study, in statistics, the estimated rate we got was, 8 per 1,000. So that's a lot of virgins out there having babies. And I don't really believe that. I don't know what you believe, but, so as a Bayesian, We believe in prior distribution. So how many virgin births have there been ever? You know, so as a Mississippi girl, I thought, well, there's Jesus. You know, and so that's one, and Wikipedia says there have been about 108 billion people. Okay, so if I have a beta prior distribution that reflects one prior virgin birth among 108 billion humans, then I get this, I like this prevalence estimate, you know, 0.3 per 1 billion live births. That to me seems much more realistic. Now, if you want to be culturally sensitive, it's not just, you know, and not just be Christian in your thinking. You know, there are plenty of demigods in the Greek canon. There's some Hindu gods. There's one Irish hero, and even Quetzalcoatl, if you want to call that human. There weren't so many New World virgin births, but that was the one I found. So you can get about up to 100 or 150 if you look at other literature. And still you have this nice reasonable mean, posterior mean of 1 per billion. Now, when we submitted this paper, we actually submitted it to a journal. The British Medical Journal has a Christmas issue. And if you want fun reading, this is a great journal issue. So they also had papers this year on James Bond's alcohol consumption and the lifetime of candies on chocolate wards, chocolate candies on hospital wards and things like that. They wouldn't let us publish these. They said they weren't scientifically rigorous. They let us publish this, 825 per 1,000, which I thought was a little bit ridiculous, but they would not budge. So it's sort of interesting. We don't really know why. We didn't ask people specifically if they had a virgin birth. You know, so obviously they could. It's measurement. Well, it's probably measurement error, misclassification, right? There's probably not that many other Jesuses out there that we haven't heard of. And some of these women maybe had a bad experience, and that's why they said they were virgins. You know, it wasn't voluntary, or perhaps they screwed up the dates, or perhaps they were Southern and they thought their mom would buy it. I can at least imagine considering trying that, though discarding that probably before I got to my mom with that story. So anyway, what caused people, or what was related to people reporting that way? So this was really interesting. Chastity pledges. So for a while, especially with religious groups, there was these pledges people would sign, you know, saying that they promised to remain virgins until they married. And so if you looked at the rate of signing these chastity pledges, first, it was really high overall in the mid-90s. And second, the virgin moms had signed them 31% of the time versus 21% of the time for the other virgins, and 15% of the time for the non-virgins who said they got pregnant. Okay, so the normal way. So maybe some of this is not wanting to be pregnant, you know, not wanting to say this happened. And then also there was a component where the women who were virgins and who had babies said they were virgins and said they had babies, because actually we didn't validate they had babies either, so they could be screwed up on the other end of that. Had parents. The parents had a questionnaire. And their parents were more likely to endorse items saying that they didn't have enough knowledge to talk to their kids about sex and birth control, or they weren't comfortable talking to their kids about sex and birth control. So there also seemed to be a parental communication, education type element to that type of reporting too. The one thing that didn't matter was sex ed in school, but they didn't have information on what type of sex ed it was. So the school could be called having a sex ed program if all it taught was abstinence only, for example, which is well known to be an ineffective, at least at the population level, an ineffective method of birth control. So this paper actually got a lot of press, which was really interesting. I've never had a statistical paper that came out in the media, but my favorite was Slate magazine, which said, better stock up on the frankincense and myrrh. We've got a lot of virgin births to get to. So I had a lot of interviews. I had some hate mail from people. We weren't trying to make fun of people. We were trying to kind of make maybe this point that with data like these, there is a lot of misclassification. People, you know, even if they're trying to be honest, can be confused by questionnaire or give different interpretations to different questions. But anyway, it was very interesting to have to be interviewed. If you ever have a chance to take a course on how to talk to the media, that's probably a good thing. I had a crash course the day before the paper was published by a guy at our school who was really good at asking hard questions, one of which was, how do you verify a woman's a virgin? I'm just like, I don't know. I'm going to ask a doctor, and I'll get back to you on that. So it's really important to be prepared for something like that. So you know, that's a little bit about. I mean, I think maybe the themes of my research are I do things I think are fun, You know, I don't think it's worth having a job that doesn't make me happy, and so I was glad to be able to have a week to talk about virgins, and all the men in my department kind of freaked out. Since we got all this publicity about virgin births, but it was okay, they lived. And so the one thing I wanted to talk a little bit about in the last 30 seconds is transitioning to biostatistics. So I do think it's something people don't hear about. Doctoral programs actually would rather have people that are really good in math than anything else. Okay, we can teach the stat, we can teach dealing in biomedical applications, but if you can't do a proof, that's going to be really hard for us to teach you as part of our doctoral programs. And so we look at people with strong math backgrounds, and there are also a lot of postdocs in biostat. A lot funded by the federal government and some funded in other sources that seek to find people who have mathematics training or statistics training or sometimes even biology training who want to move in the area. And so that's something we're always looking for. We've had a lot of success with people that have even like a physics PhD and want to make a career shift. There are lots of postdocs that help people to do that. So with that, thank you very much for your attention.